Hello class, this is Ms. Riggins with today's video on section 8.3, Trigonometric Functions, Relationships, and Graphs. As you're watching the video, please write down important notes, equations, statements, formulas, graphs. Feel free to pause, rewind, or replay the video as often as you need. And at the conclusion of watching the video, write down a brief summary about the video in your notes and submit that summary as well as a top question via the online whisk. All right, let's begin. So we've been talking about sinusoidal functions, and one thing that we learned is one of the relationships between the graphs of sine and cosine. You know, the graphs are the same, their positions, the curves are the same, but their positions are different. And how they're different is that sine is cosine shifted pi over 2 to the right, and cosine is sine shifted pi over 2 radians to the left. So that information is important to note. And we can see that here in the graph when we graph both sine and cosine. I can get the cosine graph by taking the sine graph, which is this graph right here, and moving it over pi over 2 units to the left. And I can get the sine graph by taking the cosine graph and moving it over pi over 2 units to the right. And that's exactly what this relationship talks about. All right, so that's one of the relationships we're going to talk about in the video, that we talked about in the video. Today we're going to talk about some more relationships that you may or may not know already. And this is relationships involving right triangles. So say, for example, I have a right triangle and I have an angle theta. And then, so sine of theta and cosine of theta can be computed by sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. But what if I were to find the angle of the sine of the angle phi instead of theta? Well, phi, the sine of angle phi would be the opposite leg, which is b over c. And for cosine, the cosine of phi would be a over c. Well, that looks familiar. So as you can see here, really, the sine of theta is also the same as the cosine of phi, and the cosine of theta is the same as the sine of phi. And so we call this complementary relationship because if we take a look, how are theta and phi related to each other in angle sense? That if theta and phi are in degrees, theta plus phi will equal 90 degrees. And if they're in radians, theta plus phi is equal to pi over 2 radians. And so in that sense, their relationships are called complementary. So if I know theta, I can determine phi and vice versa. Okay, let's look at another relationship. Relationships between the graphs of the sine, cosine, and tangent function. And as you recall, the graphs of the sine function and the tangent function, you already know what they look like. So they look like this. But what's the relationship between tangent and sine and theta? If you recall, this is a relationship. The tangent theta is equal to sine theta over cosine theta. So let's take a look at tangent of 0. Well, in one way we can compute tangent of 0 is we can take the sine theta and divide it by the cosine theta. So in this case, here's the cosine theta graph. So in x is equal to 0, we have 0, which is the sine of 0, divided by 1, and that's how we get 0. And when we have t is equal to, let's say, pi over 4, we have sine theta and cosine theta being the exact same value, which is pi over 2. So pi over 2 divided by pi over 2 is 1. So this value is going to be 1. But when we get to pi over 2, what we see is that cosine of theta is 0, but that's in our denominator, and we can't have a 0 in the denominator. So that means these values of sine theta over cosine theta at pi over 2, we're going to have a vertical asymptote right here at that spot. Okay, so that's the relationship as we can see, and that occurs every 180 degrees or every pi degree. So pi over 2 plus pi is going to be 3 pi over 2, and we're going to have another vertical asymptote. Okay, so a couple things that we want to talk about is that that we talked about just in summary, that the sign of a fraction equals 0 when its numerator is 0. So since the sign is always 0 at whole numbers of pi, then we have that the tangent is always 0 at those exact same values, whole numbers of pi, or multiples of pi. And since when the fraction equals 1, whether the numerator is equal to its denominator, that occurs when t is equal to pi over 4, or the reference angle is pi over 4. And that happens every 100, I think it's 180 degrees, but we go from negative 3 pi over 4 to pi over 4, 5 pi over 4. Actually, yeah. Every pi, after pi radians, from pi over 4, either to the right or to the left. And then when it's undefined, that's when you have that situation that we just talked about with the vertical asymptotes, okay? And this is the situation with the 1, and this is the situation with the 0, okay? So that's the situation. Okay, moving on. Though the functions have that type of relationship, there are very big differences. And one of the things is that even though sine and cosine have normal periods of 2 pi, tangent function has only a period of pi. The tangent function has vertical asymptotes that are odd multiples of pi over 2, where the sine and cosine function have no asymptotes whatsoever. I hope you can see no asymptotes. And even though the tangent function is periodic, pi over 4, it does not have an amplitude or a midline because it does not have a maximum or minimum value. Okay? All right, moving on. I think that was it for that page. Let's go to the next. Relationships involving reciprocals of the trigonometric functions. We haven't talked about all ratios, trigonometric ratios, but we have kind of used them. And so the relationship between cosine and secant is that they're reciprocals of one another. Same thing with cosecant and sine, they're reciprocals of one another. And same thing with cotangent and tangent, they're reciprocals of one another. But if you recall, tangent theta is equal to sine over cosine, so then the reciprocal of tangent theta, instead of being sine over cosine, would be cosine over sine. So you should know these relationships that we're talking about in depth. And to graph these, we can basically use the same strategy that we did with tangent. For example, cosine and secant theta are reciprocal relationships. Well, cosine is 1 when theta is equal to 0, so 1 over 1 would now produce this point. 1 over 0 would produce a vertical asymptote. And every time that cosine is 0, then secant will also have a vertical asymptote. And whenever cosine is 1, then secant will also be that value. So cosine is 1 at 0, cosine is negative 1 at pi, so secant is negative 1 at pi, and vice versa. And we can kind of graph in between that as well. Okay, and we can do the same for cosecant. We can do the same thing for cotangent as well. And that's what this is. We just don't have time to go through that, as you can see. All right. So in red, we have the graph of sine, and in red over here, we have the graph of tangent, and you can see that relationship. All right. We're almost finished with the relationships. One of the most important relationships is the Pythagorean relationships. In a circle, we know that the unit circle, the radius is 1. So if I were to, and because we have a right triangle, if I were to take the square of x and the square of y for every point on the graph, I would get it equal to the square of 1, which is the hypotenuse. Well, remember, x is cosine of theta and y is cosine of theta. So really that also means that not only is x squared plus y squared equal 1, but cosine squared of an angle plus sine squared of the angle is also equal to 1. And that occurs anywhere on the unit circle. And from that, we have some other relationships that we can talk about. Because if I take the inverse, the reciprocal of each side, I'll get 1 over cosine, 1 over, well, we'll get a whole bunch of different things. But this is the most important relationship to remember. And we can see that relationship here as well. And that will always occur. All right, I think that's it. Let's see. This is just a summary of what we've talked about. These are relationships that I really encourage you to memorize, and we've kind of explained what they mean, but I really encourage you to memorize these relationships because you are expected to know them. All right, that's it. Thanks.